All right, good morning and welcome to Master Talker online class. In today's video, we are going to be solving the exercises of the uh, Fundamental Physics textbook, chapter 5, which is motion. Okay, so and the first question here said that a train, question number one A said that a train moving with a speed moving with a speed of 162 kilometer per hour gradually increases its speed to 540 kilometer per hour in 10 seconds. Then I say we should calculate calculate I, the acceleration of the train. I, the final velocity velocity of the train after the acceleration. The third one, the total distance covered by the train during this acceleration. Okay, so this is very, very simple. So let us bring out our parameters. So let's bring out our parameters. So for the very first one, they gave us the first thing they gave us. Sorry, 1 minute. So all right. Okay. So the first thing they gave us is our U solution. Let me increase my marker ink. So they gave us an initial speed, that is our U. They gave us is 162 kilometer per hour, which we are going to change to 162 times 1000 divided by 60 times 60. So if we do that, we are going to have 162 times 1000 divided by 60 times 60. So I'm having 45. So they give me 45 meter per second. So for here, the final velocity they gave us is 540 kilometer per hour, which will still change to 540 times 1000 divided by 60 times 60. So we have 540. So I'm having 150. So this is 150 kilometer per hour. Sorry, 150 meter per second. So we are asked to calculate, and then they gave us the time. They gave us time here as the time they gave us is 10 seconds. So they say we should calculate acceleration. I told you that everything about motion revolves around the three equations of motion. And the first one is that what? V is equal to U plus what? AT. So the next one is that V squared is equal to U squared plus 2AS. And finally, S is equal to UT plus half AT squared. So if you look at this now, we have our U, we have our T, we have our V. So we're asked to find A. So we say that we are using the first one. So we say that v is equal to u plus what 80. So let us put everybody. Our v is equal to 150. Okay, is equal to my u is 45 plus my a is what I'm looking for, and my t is 10. So if you look at this, you're going to see that 150 minus 45 is equal to what? 10a. So therefore, 150 minus 45 is giving us 105. 105 is equal to what? 10a. So my a here will give us 105 divided by 10, which will give us what? 10.5 in what? In meter per second square. Okay, so now we have gotten our acceleration. So the next thing they say we should calculate I. Let me solve it here. They say we should calculate the final velocity after the train. So we're still going to use the same formula that say that v is equal to what? U plus what? At. Now the final velocity, now this one is going to be the last velocity here will now turn to our initial velocity. Okay, so the last velocity here will turn to our initial velocity. So we're going to have that so that is calculate the final velocity. So they say the final velocity after this acceleration. So the final velocity after this acceleration means that this is going to be our initial velocity. So we have that that our v now is 150. So we have 150. Sorry, the v is what I'm looking for, the final one. So v is equal to the initial one is 150. Okay, plus this 10.5 in bracket of what? T. Okay, so the time here is 10 seconds. They say the final velocity of the train after the acceleration. So after the acceleration, the final velocity. But the problem is that we don't know how long. Are we maintaining this same 10 seconds? That's another thing. After the acceleration. Are we maintaining my? I'm thinking if we are to maintain this 10 seconds here, the time there. But we don't know. Okay, they say the total distance covered. Total distance covered. Yes, I think we are maintaining that same time. That same time. So they say that increases from this to this in 10 seconds. So the problem here is that we don't know the time. So the acceleration of the train after that 10 seconds. They say the final velocity, sorry, of the train after the acceleration. But the problem now is the time taken. Because if we draw this in a velocity time graph, this velocity time graph, this is a velocity and our time, we have that a body moved, it started with here 45 and then accelerate this way, accelerate to a point 150. So we are not asked, they don't say we should calculate the velocity after the acceleration. Okay, the final velocity after the acceleration should be the same 150 this thing. That should be the acceleration. All right, so if you want to still calculate it, you will still get that v is equal to what? U plus 80. So we are going to have that our v is equal to, our u is 45 plus our a acceleration is 10.5 multiplied by 10, the time. So if you do that, you're going to have that v is equal to 45 plus 105. So therefore v is equal to 150 meter per second. Okay, so that is that. So that is that. Very, very correct. So we go to the next question. That is question number I. So question number I said we should calculate the distance. We should calculate the distance, the total distance covered. So we can use any of these two. So we can tell them that v squared is equal to what? U squared plus what? 2as. We can use this one. Then if we use this one, let's try to use the other one and see if we get the same answer. So our final velocity 150 squared is equal to 45 squared plus 2 times our acceleration that we got was what did we get as acceleration? 10.5. So times 10 10.5 then times s. Okay, so what do we have now? We're going to have that 150 squared. So 150 squared is giving me 22500. 22500 is equal to 45 squared is giving me 2025 plus 10.5 times 2. I'm going to have 21. So this is 21s. So if this comes here, I'm going to have that 21s is equal to 22500 minus 2025. So therefore, 21s is equal to 22, in fact, 150 squared minus 45 squared. So I'm having, this is 20475. So my s will now be 20475 divided by 21. So I'm having divided by 21. So I'm having 975 meters. So 975 meters is the total distance covered. Now, let us try to use the second formula to see if we'll get the same answer for this one. So alternatively, so if we say that s is equal to ut plus half at squared, so we say that this is equal to my u is 45. 45 times the time is 10 plus 1 over 2 times 10.5 then times 10 squared. So what we have, this is 450 plus let's do that, 10 squared is 100, okay, times 10.5 then divided by 2. So I'm having 525. So if I add it to 450 plus 450, so I'm having 975 meters. The same result. So that is that for question number 1A. So we move to question number 1B. I hope you are getting that. Yeah, question number 1B. So question number 1B said we should represent the acceleration in represent the acceleration of the train in velocity time graph. So to represent the acceleration of the train in velocity time graph, this is velocity in meter per second and then time in second. So you can say that here is 45 while here is 150. Okay, so the thing started from here and accelerates to this point 150. So that is it. And the acceleration we got, I think, was 10.5 meter per second square. So that is it. It's very, very simple to represent. So that is it. So we can just trace to the time, and the time they gave us is just 10. So here is 0, and this minus this will give us 10. Okay? So very, very simple. This is just how to represent it in the velocity time graph. So the C question said we should calculate the area under the velocity time graph. Okay, and compare this area calculated with the distance as calculated before. Okay, they say we should calculate the area here. If you look at this very well, you see that the area under this velocity time graph is so if we bring this down and decide to cut this place, see that the area we have is A and B. So we say that the area is equal to area of A plus area of B. So if you look at A very well, A is a triangle. So the area is going to be this minus this. First of all, will give you 150 minus 45 to give you 105. So here is 105. So this is a triangle which is half base times height plus this one is a rectangle, so which is just base times height. So we are going to have that this is 1 over 2 times the base. The base are all the same thing. So the base is 10 times the height. The height for B, sorry, the height for A is from here to here, which is 105 plus the base for B is 10 times the height for B is 45 minus this, which will give us 45 times 45. So we are going to have that this into this will give you 5 times 105. So I have 525 plus 450. So which will give us plus 450. so which will give us 975 meters. Okay, so you see that the area, so we will now conclude that the area under the velocity time graph is equal to the total distance covered. So that's that. That's that area under the velocity time graph is equal to total distance covered. Okay, so that is that. So move to question number 2. So question number 2, I hope you are getting what I'm doing here. Please get it. And rewind as well. Okay, I have a full video on motion. I'll keep the link on the description for you to understand very, very well. So now question number 2 said, what is the difference between speed and velocity? Illustrate this with an object moving in a particular circle. Okay, speed and velocity is that speed is just randomly, it doesn't have a direction, and anywhere you like it goes, but velocity has a direction. So we now say that speed is a scalar quantity, while velocity is a vector quantity. So question number 2b is what I'm going to be solving. We say that a body starts from rest and accelerates at a rate of 6 meters per second square for 2.5 minutes, comma. Now say then remain at the terminal speed for 4 minutes. So not before coming to rest. Abruptly in a half second. Okay, then I say I question say we should sketch the velocity time graph of the motion. So I said we should use the velocity time graph to estimate the total distance covered. So that means we should just calculate the total distance covered. Okay, so now this is very simple. Let us draw the velocity time graph. To draw the velocity time graph, we're having that this is velocity and this is our time. So velocity is in meter per second, and then our time is in seconds. So now we say that a body started from rest here and accelerates. Okay, the acceleration is in 6 meters per second. So we need to know the velocity at which this man accelerated. So to calculate the velocity, we know that v is equal to u plus at. We know this. So my v is equal to my initial velocity started from rest, so which is 0 plus my a. Acceleration is 6 times the time there is 2.5 minutes. So if you convert 2.5 minutes to second, you're going to have 2.5 times 60, so which is 150 seconds. So this is 150 seconds. So you're going to have, so which means the time it took him is 150 seconds. So we now say 150 times 6 to know the velocity, 900. So the velocity here is 900. Okay, then he maintained this speed for another 4 minutes. So if you calculate another 4 minutes, you're going to have that is 4 times 60, which will give you 240. So this is 240 plus the initial one, so 240. So the center should be 240. So to get this point is 240 plus the initial one, which is 150. So which will give you 390. Okay, finally the thing now came to rest, and it came to rest after a half seconds, right? It came to rest after a half seconds. Half seconds is simply after in a half second. That is 0.5 seconds now, right? So it's supposed to be in a half minute. Half minute is 30, but they made mistake, but let me just solve with what they have here. The half second is 0.5. 0.5. So sorry, the center should be 0.5, while this should be 390.5, because we are adding this to this to get the next one here. So that is the velocity time graph. So now this is shape A, shape B, and shape C. So we tell them that the total distance is equal to area of A plus area of B plus area of C. So if you look at A very well, you see that it's a triangle. So we have half base times height plus rectangle, base times height plus triangle, half base times height. Okay, so if we now put in our work there, we are going to be seeing that we put in our work, we're going to see that this is equal to 1 over 2 times the base here. This minus this is 150. So the base is 150 times the height is 6 plus the base here is 240 times, sorry, the height is not 6. The height is 90 minus this, which give us, sorry, 900 minus this, which is 900. So the height is 900. Okay, times the height here 900 plus 1 over 2 times the base here is 0.5 times the height is still 900. So if we do that, we are going to have 150 times 900 divided by 2. So I'm having 67500 plus 240 times 900, 240 times 900. So 240 times 900 is giving me 216123 plus 0.5 times another 0.5 times 900. So I'm having 225. So if I add everything, I'm going to be having plus 216123 plus 67500. So I'm having that the total distance covered is 283.725 meters. So that is that for that. So if you change it to kilometer, you want to change it to kilometer, you divide by 1000. So you are going to have that this is 283.725 kilometer. So if you decide to change it to kilometer, so let's go to question number this is question number 3. Okay, so let's go to question number 3. We're done with question number 2. So for question number 3, question number 3 said a stone is dropped. A stone is dropped from rest to fall freely in a location where sorry where G is equal to 9.8 meter per second square after 10 seconds. Okay, then I say number A, we should sketch the velocity time graph. Then B, we should calculate I, the velocity of the stone. Velocity of the stone. I. So we should calculate the distance. The distance covered. Okay, so this is very, very simple. So what do? To calculate this, first of all, we have to sketch it. So the sketching for question number 3, they say we should sketch it first. Okay, they say that the stone drops from a height. So let's say that this is the height. Then this stone now. Okay, let's say that this is a height, and this stone now drop here. So, and okay, so this is just the sketch. So they say we should calculate the velocity. Now, I told that everything motion revolves around the equations of motion. We say that v is equal to u plus at. So we have that v squared is equal to u squared plus 2as. And then s is equal to ut plus what? Plus half at squared. So we are looking for velocity, and they gave us acceleration. So they told us that it dropped from a height. So it was so which means if you throw something vertically upward, the final velocity is zero. So but if something is dropped from a height, the initial velocity is zero. So this thing was resting here before you now drop it. So which means the initial velocity here is zero, and then the final velocity is what we need. So let's use the first equation. We say that v is equal to u plus. Now, because this thing is going the same way with velocity, our g will be positive. So you turn your a to positive g t. But if we threw it vertically upward, it is going against gravity. So you turn your a to negative g. So know the difference. I have a full video on motion. You can go and watch it. So we have that v now is equal to 0 plus my g is 9.8 times my t is 10 seconds. So which is giving that v is what? 98 meter per second. It's very simple. So then I say we should calculate the distance covered. So the distance covered is just that height. So the distance covered is just the height. So we can use this to get it. It's very simple. So we now say that for I, this distance will now change to height. This is the distance we are looking for. Is equal to ut plus half. I told that my a will turn to what? G. So half gt squared. So which is what? 0 times our t plus 1/2 times 9.8 times 10 squared. So what do we have? So here is already 0. So I'm going to have that 0.5 times 9.8 times 100 square. Sorry, 10 square. So which is giving me 490 meters. So that is that for that. So we'll move to the next question. So the next question is giving us that is question number. They say, okay, repeat number BII above by calculating the area under the velocity time graph you sketched. The area under this. How do we calculate this area now? Under the velocity time graph. Okay, sorry. This is not the velocity time graph. So it's supposed to, first of all, we have the velocity. This is the velocity in meter per second. And then this is time. Sorry, this is time in second. So we are asked to sketch this. It is dropped from a height. Let's say that this is the height. And the height of this thing this is what me I think. So the time given is 10. This is the time 10, and then the velocity is 98. Velocity is 98, right? Yeah, the velocity is 98. Is this correct? I'm trying to check if this is correct. I don't think this is correct anyways. Okay. My mind is telling me that this should be like this, something like this. Drop like this. You throw it like this, it will fall. It will not fall. Is it going to fall like this? Oh. Wow. No, 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 no. Oh, that's the problem. How to draw this in a velocity time graph. That's the problem when a body is dropped from a height. So let us check how to draw a free falling body from a height. Okay, yes, I got it initially. So it's going to be like this. It's going to be like this. So the body, yes, I got it. This is it. Why this goes this way? So the height here is okay. So what they say we should calculate. Let me read the question again. Please follow also. Okay, the question here said we should calculate the area under this. The area under this. So if you look at this very well, this is not really a rectangle. So how do we calculate this area? I think it will be in a shape of uh, like quarter of a circle. Like if you have this, so like this one, this shape and this shape is the same thing. So that is area of a circle divided by 4. That is what I think. Area of a circle divided by 4. But the problem here is that they say that it is velocity time graph. Sketching a velocity time graph. So okay, the velocity, this is the velocity, and we got the velocity as 98. So let us check the area. I know that the area should be the height. So this is how it's supposed to be. So the area is equal to area of circle divided by 4. Okay, area of a circle, that is pi r squared divided by 4. So which pi is 3.142 times the radius of the circle is from here to here, which is 10. Yes, the radius of the circle is from here to here, which is from here to here, which is 10. So 10 squared over 4. Will you give us the same thing? Okay, that's not the radius of the circle, because if you say that that's the radius of the circle, we are getting, what about this side now? What about from here to here? That is 98. So if this is the radius, this is not the radius of the circle, because oh my god, let me check again. Okay, that's the problem, because I'm thinking that we are supposed to get exactly the same thing as the height. No, we're not supposed to get the same thing as the height. Okay, this is what I think. This is what I think. But if you know the correct thing to do, please tell us on the comment section. You say above, calculating the area under. Okay. We treat number 3b II. That is the distance covered. Above by calculating the area under the velocity time graph. Yes, I'm thinking that the area is supposed to give us 960. So what is now the problem? So if you know the right thing to do, tell us in the comment section. But if not, I'll still look at the question and then tell you the right thing to do. Okay? So I'll still look at the question and tell you the right thing to do. So let's just continue. That particular one, I don't understand. Okay. So question number 4. Question number 4 said, okay, there is no question number 4 here. Rather, we have question number 5. So question number 5 said, state Newton's law of motion. You can state the 3 of them. The first one stated that a body will continue to be at rest or a uniform motion in a straight line unless it is acted upon by an external force. The second one said that the rate of change of momentum is directly proportional to the applied force in the direction of the force. Then the last one stated that action and reaction is equal and opposite. Okay, so number 5b said, in a game of knocking two eggs together, it is wiser to keep your own egg still while your opponent knock his own egg on yours, or to ask your opponent to keep his still while you knock. Explain. Okay, so which one do you think is safer? Is it you knocking your egg, like keeping your own still, and then your opponent will knock his own egg in the game of knocking two eggs together? So are you keeping your own still for your opponent to knock on your own, or you knocking on your opponent's own? So which one do you think is safer? So tell me what you think in the comment section. I'm here for just the calculation. So tell us what you think in the comment section. Then for question number 5, that is, I think that's for question number 4, sorry. Question number 5 said that a train moving with a speed of 162 kilometer per hour gradually increases. I think I've solved this before. Sorry, that's not question number 5. Okay, question number 5C. Question number 5C. So question number 5C said a stone is thrown vertically upward at an initial speed of 216 kilometer per hour in a location where acceleration due to gravity is 9.8 meter per second square. They now say we should calculate question. Calculate the maximum height. Calculate the maximum height. You say we calculate the time. The time it takes to reach the maximum height. So time. The time it takes the stone to fall back to earth. To fall back to earth. Okay. So then the D question said in the movement of the stone in above. Okay. Is the movement of the stone on the example an example of a projectile motion? Explain. Is the movement of a stone an example of a projectile motion? A projectile motion is a motion. Okay. What do you think? Is it a projectile motion? Question number 5. By throwing a stone is okay. Sorry. Question number 5. Is it a projectile motion? You can answer that. Throwing a stone, is it a projectile motion? Me, I think it's just a free falling body. It's not a projectile motion. A projectile motion requires an angle. You understand? It requires an angle. So it's not a projectile motion. It's just a free falling body or a body that is thrown vertically upward. It's a vertical, what do I call it? Vertical motion. It's not a projectile motion. A projectile motion requires an angle. So that is what I think. So you can you can do research and know the answer for that particular one. So let's continue with it. They say that a stone is thrown vertically upward. Now it's thrown vertically upward with an initial speed. They gave us the initial speed of 216 kilometer per hour, which is what? 216 times 1000 divided by 60 times 60. So if you do that, you are going to get 216 times 1000 divided by 60 times 60. So we're having 60 meter per second. So the final velocity is 0. I told you that when a body is thrown vertically upward, the final velocity is 0. Okay. So we are asked to calculate the maximum height. Did they give us another thing? Okay, they gave us G. G is 9.8 meter per second square. So I told you that motion, in fact, every calculation of motion revolves around the 3 equations of motion that say that V is equal to U plus what? AT. And V squared is equal to U squared plus 2AS. And then S is equal to UT plus half AT squared. So we're going to use the first one. The maximum height. So to calculate the maximum height, there is no height in the first one. So let's use the second one. We tell them that V squared is equal to what? U squared plus 2. I told you that if it is thrown vertically upward, your A will turn to minus G. So it's going to be minus G then your height. Okay? So we have that that v squared, that is 0 squared, is equal to my u squared, that is 60 squared. This time that is plus 2 into minus 9.8, then the height I'm looking for. So if you do that, you're going to have that 0 squared plus do that, 60 squared is 3600. Sorry, 0 squared is equal to 3600 minus, so 9.8 times 2, 2 times 9.8. So I'm having 19.6. So 19.6 height. So this one coming here, I'm going to have 19.6 height is equal to 3600. So my h will now be 3600 divided by 19.6. So we're going to have 3600 divided by 19.6. So I'm having 183.7. 183.7 meters. So that is that for that. So the next question. Okay. So the next question here. Next question say we should do what? We should calculate the time taken to reach the maximum height. So the time taken to reach the maximum height, we're going to use the first one. So if we use the first one, we're going to have that. Permit me to clean this since we have already done I. So let's go to I. So the time it takes to reach the maximum height, we take the first one. We say that v is equal to u plus 80. So we are going to have that our v, which is 0, is equal to our u, which is 216 times our g is minus g. That is going to, this one will turn to minus g, which is minus 9.8. Then this is the time we are looking for. So this one coming here, I'm going to have 9.8t is equal to 216. So my t will now be 216 divided by 9.8. So what do we have? 216 divided by 9.8. So I'm having 22.04 seconds. So that is that, 22.004 seconds. But they're having 6.16. So what is the problem now? Let's check where the problem is. Okay, sorry, we're not supposed to use this one. Let's use the one that has no, this is what we're supposed to use. Yes, very, very correct. Okay. No, I did a very correct something. Very, very correct. This is very, very correct. We're supposed to use. Let me see what I have here. Oh, sorry, it's not 216 but 60. Please, 60 is what we're supposed to use. It's a mistake, please. So I'm having that my v is equal to u plus 80. So my v is 0 is equal to my u is 60. Sorry, 60 plus, I thought that here will be minus, so minus 9.8, then times the t I'm looking for. So this one coming here will give you 9.8t is equal to 60. Please, so t will now be 60 divided by 9.8. So that is the problem there. So 60 divided by 9.8. So I'm having 6.12 in what? In seconds. So sorry about that. I used this instead of the converted one. So the last one, they say the time it takes to reach the earth. So that is the third one. So the time it takes to reach the earth will be 2 times the small t. So which is what? 2 times 6.125, which will give you, sorry, 122, not 125. Okay, this is seconds. 1, 2. So which will give us times 2, which will give us 12.24 seconds. So that is that for question number 5. They've taken the light. So in the next video, we continue from question number 6. Bye-bye. But let me check if it is bright. Let me check how bright it is. Okay. Okay, is bright. So let's continue. So since it's bright, let us continue. Notice my iPhone makes sense. Yeah. So we move to question number 6. So for question number 6, question number 6 said is by throwing by throwing a stone inside a deep by throwing a stone inside a deep well. This is not calculation anyways. By throwing a stone inside a deep well and noticing the time it took to drop on the bottom of the well, explain how you can experimentally determine the depth of the well. Do that. It's for you to do. My own is to do the calculation. So 6b. So 6b said that if the distance s, if the distance s in meters, covered by an object moving with a time t in s, is given by s is equal to what? 2t cubed plus 3t squared plus 5t plus 7. So now say we should calculate I question the distance traveled in the first 2 minutes. They say that velocity after velocity attained after the 2 minutes. Acceleration after 1 minute. 1 second, sorry, 1 second. Okay, so to calculate this is very, very simple. So solution, the first one is that they gave us s is equal to what? 2t cubed plus 3t squared plus 5t plus 7. Okay, so the time they gave us is 2 minutes. So the time is equal to what? 2 minutes, which is certain as what? 2 times 60, which is 120 seconds. So we now have that our s will now be equal to 2 in bracket of 120 raised to power 3 plus 3 in bracket of 120 raised to power 2 plus 5 in bracket of 120 then plus 7. So we are going to have 2 in bracket of 120 raised to power 3 plus 3 in bracket of 120 raised to power 2 plus 5 in bracket of 120 then plus 7. So everything is giving me 3499807 meters. So if you want to convert to kilometer, divide by 1000, which is 3499.807 kilometers. So I say we should calculate the velocity. You know that velocity is we know that velocity is change, that is distance over time, change in distance over change in time. So which means to calculate velocity is now to integrate this. If you integrate this, you are getting the velocity. So the velocity will now be the integral of this man, the integral of 2t cubed plus 2. Okay, sorry, what am I saying? To get velocity is to differentiate this man. That is change in distance. So differentiate this. Differentiation means multiply by the power, remove 1 from the power. So if you multiply by the power, you have 6. Remove 1 from the power, you have t squared. Plus multiply by the power, you have 6 again. Remove 1 from the power, you have t. Multiply by the power, you have 5. Remove 1 from the power, you have 0. So differentiation of a constant is 0, gone. So then at 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 t equal to the same 120, that is 2 minutes, which is something 120 seconds. So we are going to have that my v is equal to 6 in bracket of 120 squared plus 6 in bracket of 120, then plus 5. So we are going to have 6 in bracket of 120 squared plus 6 in bracket of 120, then plus 5. So I'm having that it is 87125 meter per second. Okay? So they say we should calculate the acceleration. I know that acceleration is what? Change in velocity over time. Change in time. So which is to differentiate this again. Multiply by the power, remove 1 from the power to have 12t. Differentiation of this will give us just 6. And differentiation of constant is 0. So then at t equal to 1 seconds, so we're going to have that my a is equal to 12 in bracket of 1, then plus 6, which is 12 plus 6, which will give you 18 meter per second square. So you see, that is very, very simple to calculate. So we move to the next one, which is question number 7. So we are progressing. I hope I'm not rushing too much. Okay. So if I'm rushing, you rewind it 10 times to understand perfectly. So for question number 7, so question number 7 said a body moving with uniform velocity. Okay, they said that you decides to change its velocity. A body moving with uniform velocity u decides to change its velocity at time t equal to 0 by increasing its acceleration uniformly at a rate y for t seconds. If the initial acceleration is a, and I say obtain an expression for the velocity of this particle during the period of acceleration, that is from t0 to t. So then I say I obtain also an expression for the distance covered. Okay, so now the first one is that they say we should obtain what? First of all, they say we should obtain the expression for the velocity. Now for the velocity, we know that change in v will now be the integral. The v itself is equal to the integral of that yt. Okay, the integral of yt plus a. Yeah, now have dt. So what do we have? Let's go again. A body moving with uniform velocity u, okay, uniform velocity u, decide to change its velocity at time t equal to 0, by increasing its acceleration uniformly at a rate of y for t seconds. So the acceleration is equal to y for the t seconds. So the second t is t seconds. So then I say we should, okay, its uniform as then I say if the initial acceleration is a, okay, the initial acceleration is a, then I say we should obtain an expression. We know that v is equal to u plus at. We know this formula, right? Okay. initial acceleration is A. Okay, so that means my V will now be the integral of what am I saying? Okay, U plus AY, sorry, YT, U plus YT, then T. So what do we have now? So this is going to give us UT plus YT squared over 2. So what do we have? Plus a constant. Let's say that U is our constant. So what do we have here? Okay, this is going to be A. Yeah. So the initial, they were supposed to say that the initial velocity is A. Initial velocity is A. That is it. The initial velocity is A. So this is how it's supposed to be. Yeah, plus a constant. So this is the expression here. So, and that is what they got here. Yeah, AT plus YT squared over 2 plus U. That is it. So the next one they say we should calculate is what did they say we should calculate again? Obtain an expression for the distance. When we have velocity, to calculate distance is to integrate again. So if we integrate this thing again, we're going to have that this is the integral. So the distance will now be the integral of AT plus YT squared over 2 plus U. So which will give us AT squared over 2 plus YT cubed over 6 plus UT plus what constant are they using? Is there any constant they're using? UT plus, yeah, so plus any constant. So that is the expression. Okay, so plus any constant. So we move to the next one, question number 8. Question number 8 said, what is projectile motion? You can answer that. You know that. What is projectile motion? So they now say that so for 8b, let's calculate 8b. 8a say what is projectile motion and give 7 examples of projectile motion. You can do that. You can Google that and get your answer. So let's move to 8b. Question number 8b. Let me check if my this is still moving. Okay, yeah, it's still going well. So for 8b, 8b said a ball is kicked. A ball is kicked into the air. A ball is kicked into the air at an angle of 30 degrees to the horizontal. And at an initial velocity. Let me refill my marker, please. No, we are in the Harmattan season, so it always gets dry. Okay. So at an angle, okay, they say that at an initial velocity of 100 kilometers per hour, you now say I sketch the velocity time graph. I. They say we should calculate the maximum height, H max. Calculate the maximum height, comma, I. The total time. The total time of the flight. Total time of flight. So IV. So we should calculate the range. Okay. So for the sketch, this is velocity and this is time graph. So it is projected like this. So this is the velocity of projection. and the velocity is 100. So let's calculate the velocity. Our u is equal to 100 kilometer per hour, which is 100 times 1000 divided by 60 times 60. So let's do that. 100 times 1000 divided by 60 times 60. So we're having 27.8. So 27.8 meter per second. So here is the u, 27.8 meter per second. So this is our angle, and our angle is 30 degrees. So that is that. So let us calculate the first one, the maximum height. What's the formula to calculate maximum height? The maximum height is given by u squared sine squared theta over 2g sine squared theta over what? 2g. So we're having, how do I remember this? I remember this that u squared, if since it's 2 here, 2 should be here and 2 should be down. That's how you remember it. So you have 27.8 squared times sine 30 all squared, now divided by 2 times. Let me use 9.8 since they did not give me the one to use. So let me use 9.8. So if you do that, you are going to have, this is 27.8 times another 27.8 times 0.5 times another 0.5, then divided by 2 times 9.8. So if you do everything, you're having 9.86. So I'm having 9.86 meters. Okay? So that is for the first one. So how am I getting 9.86 meters? Let me do it again. 27.8 squared in bracket of sine 30 and 30 squared, then divided by 2 times 9.8. Okay, yeah, 9.8 is very correct. So what did they get? Yes, 9.8 is very correct. 9.8 is very, very correct. So we move to the next one. That is question the total time taken. So first of all, we need to know that that the small t is equal to, I think, 2u sine theta over g. Yeah, 2u sine theta over g. Sorry, u sine theta over t. So the total time is when you apply the 2. Small time is what? U sine theta over g. So the big one is 2, the small one. So the big one is equal to 2 of the small one. So that is why we have this. That is 2 times 27.8 times sine 30 divided by 9.8. So if we do that, we are going to have 2 times 2, 27.8 times 0.5 divided by 9.8. So if you do that, we're having a 2.8. Is that what they got? Okay, yeah. Sorry. That's a mistake. So this is the small t. Yeah, sorry, this is the small t. The small t is given by 2u sine theta over g. Let me even check. I've even forgotten all these formulas. Okay, but we can still get it though. We can still get it. We know that v is equal to u plus at. And projectile motion is when this thing is moving up. So moving up is against gravity. So this is my final velocity is 0. This one is what? U sine theta. Okay, then minus gt. You get that? So this one coming here will now have that my gt is equal to what? U sine theta. So my t will now be what? U sine theta over g. I'm very correct. So the bigger time is now this. So the bigger time is now this. So if you do that, you're going to have 2 times 27.8 times 0.5. Sine 30 is 0.5. Then you now divide it by 9.8. So I'm very correct. 2.8. So this is 2.8 seconds. So very, very correct. 2.8 seconds. So we move to the next one, the range. So for the range R is given by u squared sine 2 theta over g. This is the only one that is weird. So we're going to have that 27.8 all squared sine 2 times 30, then divided by 9.8. So which is what? So do everything, sine 60. So we have 27.8 times another 27.8 times sine 60. So you now divide it by 9.8. So I have 68.2. So 68.20 meters. So that is that. So we'll go to question number 9. And I think that is the last question here. So question number 9 is the last question. So question number 9. Question number 9 said that what is the condition for a body to be described as a projectile? Well, I think when it has an angle. So that is what I think. But you can make the research. So they said that 8b said that a stone is thrown from the top of a cliff 150 meter high 150 meter high from the sea level at an angle of 30 degrees below the horizontal, and it hits the sea 40 meter from the bottom of the cliff. Okay, then I say we should take G as 9.8. Okay, so 9.8 meter per second square. All right, so then I say I question we should calculate the initial speed. Calculate initial speed. Calculate the initial speed. So I said we should calculate the direction in which it is moving when it hits the sea. The direction. The direction in which it is moving when it hits the sea. Okay, so that is very simple. So first of all, we can draw it. If we draw the diagram, we will understand what we are actually asked to do. So now, first of all, solution. I have a cliff. This is my cliff that is 150 meter high. Then this is the top of the cliff. We now have a projectile motion that fall down like this. Okay. So, and this is my angle. This is initial velocity, and then this is my angle, 30 degrees. So they gave us that from here to here, that it fell from here to here to be where is it? 40 meters. 40 meters. So which means here is equal to 40 meters again. So in other words, they gave us the range. So we know that range is equal to what? What's the formula for that range again? Range is equal to u squared sine 2 theta all over g. So we have that 40 is equal to u squared. I don't know my u. Then sine 2 times 30 and divided by 9.8. So to cross multiply, we're going to have that u squared will now be 40 times 9.8 divided by sine 60. So let's do that. 40 times 9.8 divided by sine 60. So we're having that our u squared u square is equal to 452.642611. So u will now be the square root of this my answer, 42452.642611. So we now have our u. So the square root of this my answer becomes my u, that is 21.27. 21.2728 approximately 28 meter per second. So that is my u. Okay. So that is that for my u. Then for my v, so we used the range. But if we want to use the height, can we use the height? This is okay. They say that it hits the sea 40 meter from the bottom of the cliff. 40 meter from the bottom of the cliff. Yes, 40 meter away from the bottom of the cliff. So this is the right thing to do. So the answer is 21.21. Let me check. Here is the answer. Okay, they got 9.08 meter per second. How did they got that? It hit the sea 40 meter from the bottom of the cliff. 40 meter from the bottom of the cliff. It is the sea 40 meter away from the bottom of the cliff. This is the right thing to do because it hit the sea 40 meter from the bottom of the cliff. So from here to here is 40. So if from here to here is 40, I think that from here to here is equally 40. So that is that. Okay. So the next thing they say we should calculate is what? They say we should calculate the direction. For us to get the direction, problem. But this is what me I think we are to do. 40 meter away from the bottom of the cliff. 40 meter. It is the sea 40 meter. Yes, this is exactly what to do. So for the direction, I don't know how to calculate the direction. Can't get the direction. So if you know how to calculate direction, you can tell us on the comment section how to calculate. So the last question is question number 10. So and I'm done for this. So question number 10 said a table tennis, a tennis ball A is projected from a point O with an initial velocity of 50 meter per second at an angle of 30 degrees to the horizontal. And I say at the same time, at the same instant, comma, another tennis ball B is projected from a point K in point A in the opposite direction. With an initial speed the initial speed 40 meter per second from from a point from a point level O, and OK is equal to 120 meters. Assuming the ball collide, assuming the balls collide, then we should sketch the trajectory of the ball. So this is trajectory motion. It's not a projectile motion, but a trajectory motion. One coming from the other end, another one coming from the other end. So I have this and this. Okay. So we have the first ball. We have this one coming this way. Sorry. The first ball coming. This one coming. So that is it. So this one came with an initial speed of 40 meters per second, while this one came with an initial speed of 50 meters per second. So what else? But this one is with an angle of 30 degrees. But this one, they did not give us the angle. So let me call it theta. So let's see what they are asking us to find. So now, they say we should determine the angle of projection. Determine the angle of projection. I mean, the angle of projection of the second ball, because they gave us the angle of projection of the first ball. So they now say, determine the time of collision, the time it took them to collide. Then they say that we should determine the vertical displacement of the ball. The vertical displacement of the ball, okay? So for the very first one, they say we should calculate the, okay? So we know that, let's say that the range, we know that the range is equal to what? Don't forget formula for range. What's the formula for range? U squared sine 2 theta over G. That is our range. Trying to get something. Okay. So the distance here is 120. So they gave us that the range is 120. The range is 120. So for this first side, we have that. Okay, let us try something. Can I say that 120? The distance from here to here is 120. But the problem now is, if we don't know how far this one. Okay, they collide here. Since they collide, so there's no range. So let's just use equation of motion. Equation of motion that says that S is equal to ut plus half gt squared. Let us use this thing. So the distance I'm using should be 120. Okay. Why am I using 120? Okay, let's say the distance of y. So where is the first ball? Ball A and ball B. So distance for ball A is equal to, the initial velocity is 50 times t plus 1 over 2. Okay, it is negative because it's going up against gravity. So this is negative. But this is 50 sine 50 t sine 30. What is the time? Are we giving the time? Okay, we are not giving the time. There is problem. Okay, 50t, then minus 1 over 2 gt squared. Okay, then S for B should be what? 40t sine theta minus 1 over 2 gt squared. So if we compare equation 1 and 2, we will now have that 50t sine 30 is equal to 40t sine theta. So t cancel t. So we have that sine theta will now be 50t sine 30 divided by 40t. So what do we have? So t cancel t, we have 50 sine 30 divided by 40. So I'm having 0.625. 0.625. So if you do the sine inverse of that, shift sign answer. I'm having 36 points. 36 point that. So 36.7 approximately. So can I clean here? Yeah. If I clean here, I'm going to have that theta. Theta will now be the sine inverse of that 0.625. So which will give us 38.7 degrees. So that is the angle of projection of that. So the next one, they say that we should calculate the time of collision. So for the time of collision, we will do the same thing. So for the time of collision, let me solve it here. The time it will take them to collide. So we're going to use the same thing again. We're going to say that our S is equal to what? Ut minus half gt squared. So we're having that that is for x, for a. So now S of a will now be, our u is 50. So 50 t that I don't know. But since I'm talking about horizontal projection, all St. Teresa's College. So this one is moving towards the angle. The other time we are talking vertically, so we will use sine. So this one we're going to use cos. So cos theta, cos theta. Okay? Minus half gt squared. Okay? So S of B will now be 40. Okay, the theta here is now 30. So 40t cos what did I get? Cos 38.7 minus 1 over 2 gt squared. Okay. So if we now add the two of them will give us 0. That will give us the total distance here, 120. So S total is what? S of A plus S of B. So this is 120 is equal to, this is 50t cos 30 plus 40t cos 38.7. So ignore this side. So we're going to have finally, so if you do everything, you're going to have 1.6. If you collect like terms and do everything, you have that your t will now be 1.6 seconds. So thank you very much for watching. Please like, share, subscribe. Bye bye. I'm tired already.